Good morning. Chapter 10, Lesson 4 is on page 443 and 444. We're going to be doing a mouthful today, adding and subtracting rational expressions with like denominators. So the denominators are always going to be the same. So just like we used to do with fractions, we had 3/5 plus 4/5. As long as the denominators were the same, all we had to do is add up our numerators, and we end up with 7/5. We're doing exactly the same thing today with our problems number 11 and number 33. Let's start off with something simple. The denominators for number 11 are the same, so that's a good sign. So we have y plus 2 in the denominator. We're going to put everything together in the numerator, so we have y squared plus 5 minus 4y minus 17. Remember, we're changing the sign of everything inside the parentheses in that 4y plus 17. So we can take a look at this. We can combine like terms. We end up with y squared plus 5 minus 17 is a negative 12. So we have y squared minus 4y minus 12 divided by y plus 2. And we know from chapter 6 that y squared minus 4y minus 12 turns out to be y minus 6 times y plus 2. We can use the box, or we can just kind of do it mentally. And we have a y plus 2 in the denominator. So we can cancel out like terms, y plus 2, numerator and denominator, and this simplifies to the quantity of y minus 6. So there's our solution to number 11. Let's go from something simple to something way complicated, number 33. We have three terms, and luckily they all have the same denominator. So let's make one huge line and stick everything underneath that same denominator. So we have 3x squared plus 4x minus 12. And remember, we're going to change the sign of everything inside the parentheses because we have minus signs in front of them. Minus 5x squared plus 2x plus 6. We have a 14x squared, we have a 4x, and we have a minus 2. Over the quantity of 3x plus 4 times the quantity of x minus 1. So let's see if we can combine terms in the numerator. Our denominator is going to be the same, obviously, 3x plus 4, x minus 1. And we're going to start off with 3x squared minus 5x squared plus 14x squared. That gives us a 12x squared. 4x and a 2x and a 4x give us a 10x. Minus 12 plus 6, is a minus 6. Minus 2 is a minus 8. So I guess we didn't have to make our line quite as long. Let's get rid of some of this line so we can continue. Oh, I guess I can't do that. So let's see if we can simplify this then. We have the quantity, use my ruler again. We're going to factor out a 2 off the top, which ends up with a 6x squared plus 5x minus 4, and we're going to have in the denominator a 3x plus 4 and an x minus 1. So let's see if we can factor 6x squared plus 5x minus 4. So we have a is equal to 6, we have b is equal to 5, and c is equal to negative 4. We have some beautiful music in the background. The alarm is going off. So we end up with a minus 24 in the numerator, a plus 5 in the denominator. We're going to end up with a plus 8 and a minus 3. So we have an 8x and a minus 3x that we're going to place. So let's stick in our 6x squared. Let's stick in our 4. Let's stick in our minus 3x and our plus 8x. It's 11 o'clock in the morning, so the chimes are going off. So we can look at 6x squared and minus 3x, and we'll see that we have in common a 3x. And if that's a 3x, we end up with a 2x in the numerator, a minus 1 up top, a plus 4 down below, and our final check is a minus 4 in the box as it should be. Got myself scared for just a second there. So we have 2x minus 1 as a factor. We have 3x plus 4 as the second factor. Let's go back and use that in our page. We have 2. We have 2x minus 1. And we have a 3x plus 4. And our denominator turns out to be 3x plus 4 and x minus 1. So we can finally get this almost simplified by canceling out like terms. We have a 3x plus 4 and a 3x plus 4. So when we cancel those out, our numerator ends up being 2 times the quantity of 2x minus 1. And our denominator ends up being x minus 1. So our solution is simplified to that shown in the box. We go slow, they look complicated, but if we break them down and we use our box method, things work out. Thanks so much. We'll see you all tomorrow.